Well, welcome to Bucksport. Welcome to the Center for Professional Mariner Development. Welcome to Maine Maritime Academy. Welcome to this wonderful event. It represents an extraordinary amount of work, effort, planning, and future thought by so many in this room. I want to thank each and every one of you for participating today on one of the driest days we've had this month. There are many people whom I'd like to thank for their support in getting us all to this special moment, one that I think we'll look back on for many years to come as another start towards a next level, a next evolution, and a next era for the partners who will be speaking here today. I certainly want to reach out and say a special thank you to the Maine Community College System, to Northern Maine Community College, and to Diamond Offshore Wind. Unfortunately, not everyone was able to attend today, but I'll still want to walk through those who were very important in bringing this together today. Some of our members of Congress from Senate and House wanted to be here today, but their calendars prevented their attendance. We're very proud and appreciative that their representatives are here with us. Certainly Governor Mills and her administration have shown incredible leadership on reducing Maine's carbon footprint and the Maine Won't Wait Climate Action Plan. We thank her for her leadership and foresight into the offshore wind industry and what it can mean for our state. So thank you. Please, her representatives here, please extend our debt of gratitude to her. Her themes on this are precisely tailored to and consistent with those that are taking place throughout the global maritime industry, as well as together all across this world. We are working actively on efforts to reduce the carbon footprint of more than 100,000 ships across all of the oceans. Senators King and Collins, who wanted to be here but who are here in spirit and in funding, they've helped us a lot, and we appreciate them for their leadership on these issues. They've championed the grants that will support the programs that we are discussing here today. I'd like to recognize Representative Ron Russell. Would you please stand, Representative? Thank you for being here with us, and he's been a leader in the Capitol on these issues. Had an opportunity to see him in action and applaud him for a wonderfully successful first session. He's also been very supportive of Maine Maritime Academy and higher ed in Augusta. Thank you for being here with us, Representative. I'd like to recognize Senator Grohosky and Representative Milliken. They both wanted to be here but had travel plans that could not be rearranged at the last moment, but they've both been very supportive of these initiatives here. Thank you to our supportive board members, both near and far, and those who are here today. A few that I know that were going to make it, I don't know if they did. Elizabeth True, is Dr. True, I'm sorry? Oh, she's on her way in. Morton Arnson, one of our trustees, I don't know if he made it yet, or he may come later, and Professor Susan Loomis, I think, there's Professor Loomis, thank you for being here, and of course Paul Mercer, who will be introduced here in a moment. MMA would not be here and participating in this event without the foresight of Dr. Keith Williamson, our provost. Thank you, Keith, for all that you have done. Your work as an advocate for evolving our curriculum and marinizing programs, both internal and external, has been transformational for Maine Maritime Academy, and your efforts and vision on this event were critical to pulling it off. Tim Acorn, our director of the Center for Professional Mariner Development, thank you for all that you and your team have done here at the CPMD, and thank you for your leadership and dedication in many initiatives of CPMD. Professor Sadie Ali Ferreira, Bucksport native, thank you for being here, Professor. She's been a great leader on power engineering technology topics, both curriculum and training, and just a great mentor for our students at Maine Maritime. Thank you for being here. To our partners at the Maine Community College System, President Dave Dagler in the back. Please turn and recognize President Dagler. He's been a great leader of the system, a great partner with us on initiatives in the Capitol, and also a steady hand and guide, and at times even a bit of a hoarse whisperer for me personally. So thank you, President Dagler. Northern Maine Community College President Tim Crowley is with us. Right here is President Crowley. Thank you for being here again. It's nice to spend some time with you here in the Bucksport facility for a second time. Thank you also to Wind Power faculty Wayne Kilcollins from NMCC. Look forward to hearing your thoughts from the faculty side later this morning. And Chris Weissman, CEO of Diamond Offshore Wind. I spoke with Chris a little bit ago. There he is on the panel. Thank you for your work on behalf of the state and for everybody in your extensive team of subject matter experts. Your technical leadership and your business leadership in this space is superb, and Maine is lucky to have you and lucky to have Diamond Offshore Wind. We are lucky to have Diamond as a partner. Also want to recognize some folks who without whom this event could not have been pulled off. Rhonda Varney, where is Rhonda? My trusted assistant and leader of so many initiatives that were part and parcel of bringing this together, along with Kate Noel. And Kate, I think everybody has now met you, and the two of them together have done so much to make the logistics of this all work out. Today is indeed a fruitful step in broadening the scope of Maine's efforts in offshore wind, but also in the necessity of broadening Maine's workforce training in order to support it. Clean energy is at the forefront in Maine and the maritime industry, as I said. MMA is proud to lend its expertise to a cause that will mean more access to more jobs for more Mainers. We are marinizing the workforce in every way that we can through this partnership and others here at CPMD, certainly along with the Maine Community College System and our partners within the University of Maine system and our private sector stakeholder partners and experts such as Diamond Offshore Wind. I'd like to now bring to the podium a person who is a personal friend, a professional colleague, and a subject matter expert on a host of topics that we will touch on today. All of you, most of you anyway, know Mr. Paul Mercer. He's local, like Sadie. He's a Bucksport kid and graduated from Maine Maritime Academy in 1973. After 5 years aboard merchant ships, Paul has held senior management positions in energy, the environment, and academia. He has held numerous positions at Maine Maritime Academy, both with the faculty and the administration. He's served as Maine's Commissioner of the Department of Environmental Protection and currently is concluding a term as Special Advisor to the Governor on offshore wind. Paul resides in Penobscot with his wife Brenda and enjoys time with his two grandchildren and special granddaughter. And I'll editorialize here. Paul is a pioneer in so many ways. He was a professor when I was a student at Maine Maritime Academy, and he was on the leading edge, if you will, of MMA evolving its programs well beyond pure maritime applications on shipboard. He was part of that group that was developing the power engineering technology programs, and he and some fellow graduates of his had already demonstrated how the engineering and logistics and focus, the hands-on and minds-on applications of operating ships at sea could apply to shoreside power systems. And he and his colleagues had already traveled throughout the state and the Northeast and helped many others come up with more efficient and more effective ways to operate their plants and in some instances design them. And he brought that back to Maine Maritime Academy and began teaching there. There was a whole a young generation of future engineers, me included, who were fortunate to be in front of him in classrooms and hear him tell the stories about how there was this dual application. He was tremendously influential on the development of those programs, and he was tremendously influential on the development of that generation of engineers. Ask me how I know. He is a long-standing friend, as I said. He is a long-standing mentor of mine and a current mentor of mine, and I suspect will be for some time as I learn a little bit more here and there about how to be a president. Paul's been a great aid in that as well. Finally, as I bring him forward, I can tell you he is a great Mainer and he is a fine man. Paul Mercer.
Thank you, President Paul, and welcome to Bucksport. This is kind of the, like to refer to as the area of nowhere in Maine. If you stop and think about it, the mid-coast area of Maine is often designated by east of the Kennebec to the west of the Penobscot. So that's mid-coast Maine. And then down east Maine actually starts somewhere like Rooster Brothers in Ellsworth up. So the west side of the Union River to the east side of the Penobscot River is nowhere. But it's the best place there is in Maine. So we have Bucksport, Olin, Penobscot, Castine, Brooklyn, Sedgwick, Blue Hill, Surrey, Trenton. You know, it's just a great place to live, and it's an honor to be part of it. And I've actually been part of it for quite some time. A number of years ago, Dr. Habib Dagger at the University of Maine contacted the Maine Maritime Academy and asked us to partner with them in the Volturnus project, which was a 1/8 scale wind generator that they wanted to deploy off Castine. Captain Dana Willis, Captain Tim Leach, Captain Harry Stevens, Captain John Worth put together the plan to attach, tow, anchor, and deploy this 1/8 scale off Castine. The trick was this 3-legged stool was actually in Brewer, and they wanted to tow it to Castine down the Penobscot River, which has currents of 12 to 14 nautical miles per hour of whatever, it's fast, all right? The hull was only designed, it could not exceed 6 nautical miles per hour. And you're going into a 14, 12 knot current and all that, so it was a very, very interesting tow, and the guys pulled it off not only successfully but safely. And then the unit was deployed off Castine for the next year or so, gathered information and data from that, and that data and science that they acquired from that allowed the technology to move to the next level, which is full-scale deployment. And when it came, that part of it, it just worked well. And that was a very good team that was put together to do that. A few years ago, I had an opportunity to work with President Crowley and his team at Northern Maine Community College on a separate project. They had an idea, they had a plan, they had an implementation program to make the plan succeed, and they did it. And I worked with professional and committed people at Northern Maine Community College, and they had a good team, and they have a good team, and the program is still running today. Governor Mills, her energy office, DMR, DOT, Maine Port Authority, and other agencies within the state have all been working hard and are fully committed to offshore wind responsibly developed in the Gulf of Maine. Responsibly developed in the Gulf of Maine. That's a good team. Many years ago, I had an opportunity to work with Diamond Generation in Maine at a power project, an energy project, and it was successful and it worked out very good, and they had a good team together. From there, over the last 30 years, Diamond has morphed and evolved and diversified and is now one of the global leaders in offshore wind. And they have a good team. So when you take all of the good teams that have been around and are in place right now, the region, the coastal states, and the global commitment to offshore wind is evident by the state's commitments, by the federal energy, environment, and policy that's in place now, and the equity resources who are committed to offshore wind and the billions of dollars they have already committed. Looking at the global siting of offshore wind, the science and the data shows that Maine and the Gulf of Maine are a top spot for locating offshore wind. It's an amazing natural resource to do that. When you look at the state of Maine, it has, as a state, and regarding offshore wind, the state of Maine has open water access. We have the technology from the University of Maine. We have the infrastructure in place. We have the onshore and offshore expertise to make this happen. We have the Maine-based companies who are capable of making this happen, and we have the workforce to make us a leader in the offshore industry. The state higher ed system working together through partnerships, research, program collaboration, provide tremendous economic benefit and opportunity to the state, its community, and its people. Offshore wind is coming to the Gulf of Maine. Our neighboring states to the south are actually making huge financial commitments to port infrastructure and supply chain in support of the offshore wind industry. I believe, I had the privilege of working with Governor Mills and her administration for a little over 3 years. It's time for me to move on to something else, and so I believe, I'm not speaking, I believe that we are, as a state, are on the right course to responsible, sustainable, and valuable offshore wind development in the Gulf of Maine. I believe our state has what could be called the opportunity of a century, and we have the team in place to make it happen. I'd like to give a very special thanks to our Washington delegation and their support of offshore wind, and a very special thanks to Senators Collins and King for their unwavering support of the Gulf of Maine and offshore wind, and they are the reason we're here today. The training that will be provided from this center is a very important step to future opportunities for the people of Maine, our children, and our grandchildren. And so let's do this, let's do it right, let's be responsible, let's don't legislate ourselves out of it, let's make it work, and let's do it and do it right. As someone once said, we can't wait. So it's good. So thank you very much.
Coming in on a nice day like today, once you get uptown, up at the top, and you open that hatch and take a look at the view, and it's quite fulfilling, and it's beautiful to see.
The student that's going to come into this program is going to want a little adventure. They want excitement, they want to work with their hands, but they also have the opportunity to grow professionally because there are many other opportunities in the wind industry to move up.
I've been working here now for almost 7 years. I graduated out of MCC's wind power program back in 2016. The skills for the job are quite diverse. Walking in, I had a good baseline knowledge of electrical and mechanical and things that were broad scope. We have our hands in a little bit of everything here, so definitely fun and interesting.
NMCC pursued a partnership with Maine Maritime because we think the future of renewable energy includes not only onshore wind, but offshore wind. So we are in the process of working towards developing training that will provide the global wind organization standards for people who want to work in offshore wind. This is a long-term project. It will take 8 to 10 years for offshore wind to develop, but we're on the ground floor with Maine Maritime Academy delivering and developing this instruction.
It's really good that different schools in Maine do cooperate, and they have a lot of great students that can benefit from the different skills that both facilities and both organizations provide. The technical skills that are required for both institutions are a perfect match, and we can hone in on the maritime skills while they hone in on the technical aspects of the wind farms themselves. And so for us to partner and work to our strengths, it's going to be a perfect match.
Well, the Maine Community College has an outstanding wind power program with some of the unique courses that aren't available in other parts of New England or eastern United States. The Department of Labor says that there's going to be a 40% increase in the need for wind turbine technicians in the next 10 years. The proposal that's in front of the legislature and the Maine Public Utilities Commission is for roughly 180 wind turbines. One of the other benefits for Long Road Energy and the King Pine project is having educational resources.
Right out of the gate, just as a new hire, I would expect $50,000 to $60,000 a year on average. As you get more experience in the field and you gain more skills and you become more valuable to the companies, the opportunities to make over six figures are definitely there. Then if you go into development and things beyond that, you're looking to do even more.
I've been a traveling technician for 3 years now. I've got to go all over the country, from California to Iowa to Texas, all the way up here to Maine. Another thing that I enjoy being a wind technician is the great views going up the wind turbine. Places like Oregon, you got the Columbia River Gorge that you get to see from up tower. It's just beautiful views everywhere you go.
There's one simple hearing hack anyone can use to improve their hearing almost overnight.
Thank you. Good afternoon, everyone. My name is Keith Williamson. I'm the provost here at the Academy. And it's my pleasure to introduce the Roundtable and ask them some questions. So before I do that, let me start off with the panel. So President Crowley, would you please all introduce yourselves?
Good afternoon. I need to remind Paul that there are many beautiful places in Maine, and if you go north of Millinocket, but nice to see you all here today, and President Degler and Becky Smith, nice to have you with us today. My name is Tim Crowley. I was the president of Northern Maine Community College up in Prescott. I've been the president there for about 20 years. I've been in the community college system for over 30 years in a variety of positions at the same institution, in the students as well as academic dean for 9 years. The workforce challenges we face are going to require us all to work together to address the challenges that Maine has. My involvement with this project and with other projects that are associated with renewable energy, I'm very proud of the work we've done with biomass energy on our campus and our region is important to us, as well as solar and heat pump technology. So I'm very proud of the project we developed. I'm originally from Lewiston, Maine, but spent most of my life in Aroostook County, and that's where I'm going to end my time, I think, is in Aroostook County. Thank you very much. Nice to meet you.
Thank you.
With the college now, goodness, be 15 years come January. And President Crowley and I had an idea way back when, and we said, well, with all of the technology that's going on towards renewables, have a program that would train technicians to do the job. I guess you could look at it like the rollout of the cars back in the early 1900s. You could have cars everywhere, but if there's no one to fix them, they'll be sitting on the side of the road. So had an idea, and we knew what needed to be done for the training. I had worked a couple years in the technology with General Electric, and so I brought that to the table along with my mechanical engineering background to see how we could get technicians the knowledge and the skill set to be able to go out in the field and fix the turbines. The biggest thing to find out with the students is, or the first question should be, do you mind climbing? Okay? That's usually the first thing when they come in for an interview is, do you like climbing? And they're like, oh, okay, yeah, I can climb a ladder. I said, well, 300 feet in the air. A lot of the newer equipment has a crew lift, but they still have to know how to climb. Okay? If something happens with the crew lift, can't call it an elevator, it's got to be a crew lift. They still have to go 300 to 400 feet in the air to work in their office. And as one of my previous students mentioned, the view from the top is awesome. So giving them the training to do that was the goal, so that we had the workforce to do the job.
Excellent. Well, good afternoon. I'm Chris Wisman, CEO of Diamond Offshore Wind, and I'm really honored to be up here with this esteemed panel. It's a fascinating time. Jerry and I were talking about trips to Europe and seeing the amount of wind turbines that have gone up in Europe over basically the last 20 years when they really started putting them up. And there's now thousands up, and the industry has matured in Europe to the point where you have what are called hotel ships, so that maintenance workers don't have to be on a vessel going 40, 50 miles offshore to work, working for a few hours, and 40, 50 miles back every day. Instead, they go out 2 weeks on, live on a vessel that literally has all of the amenities, right? Food, sleeping, everything you can, and come back to port. Now, that is an emerging opportunity for Maine, for people that live and want to continue to live in Maine, rather than necessarily shipping off to Gulf of Mexico, right? A lot of graduates head to big marine services now. So it's really, I think, as Paul said, it's once in 100 years, once in a generation. What we're seeing is a marine construction boom that is going to be coming over the next decade that is really once in a lifetime to actually make that kind of Maine built. We'll talk a little bit about the role of the research array and things like that and what's coming, but glad to be here. Thanks, everybody.
My name is Sadie Ali Ferreira. I'm a 2003 graduate of the Power Engineering Technology program at Maine Maritime Academy. My background is construction. I went and worked for Chimbro after graduation and built power plants. I also worked right here at the paper mill for 5 years in maintenance and reliability. Started a family and decided that I didn't want to be working those types of hours with 2 little ones. So I went back to school and got my master's degree in education from Hudson University, and went back to Maine Maritime Academy to teach. So I'm really happy to be able to be teaching at Maine Maritime Academy in the same program that I graduated from. I kind of feel like it's come full circle for me. I'm now the program coordinator for the Power Engineering Technology program. So I've made some changes to the program since I've been back. One of those is starting a new onshore and offshore wind energy class that's right now an elective, but it will be part of the program coming up. So I'm excited to talk about those things today and to share some of the things that we're doing at Maine Maritime Academy. So next.
I'm Tim Acorn. I graduated from the Academy in 1979, went and sailed for 19 years. Took my direct commission with the Navy when I graduated, so I did 28 years with the Navy. So I've been doing a lot of different things. I was teaching before I found my way back to the Academy in 2015. I've been part of the continuing education department, which is now morphed into Center for Professional Mariner Development, since I came back in 2015. And I now am the acting director for the past 2.5 years. Been working with Wayne the past year and a half, getting ourselves into the understanding of how we're going to grapple with the offshore wind safety training. Wayne's going to be doing the technological aspect of it and training the technicians, and what we're going to be doing here is the safety aspect of the offshore wind.
All right. Okay, thank you, panel. Thanks, Tim. All right, now for some detailed questions. So first question, directed at you, President Crowley. Could you please explain the significance of the MOU between NMCC, the Maine Community College System, MMA, and Diamond Offshore Wind?
I think the significance of it really represents a change in the way we're going to have to do business to meet the workforce needs in the state of Maine. The collaboration of business, industry, and education will become the way we move forward. the ability to develop short-term training programs so that people can achieve the appropriate credential or certification so they can move forward will be critical to the development of our economy. So I think the collaboration between, if you really think about Northern Maine Community College and Presque Isle, Maine, collaborating with Maine Maritime Academy, what would you really think we would do together? Anything? But the world is changing, and there's an opportunity here to share expertise and share the passion we all have for meeting the workforce needs of the state of Maine. So the state is getting smaller in terms of technology, in terms of our ability to communicate and work together. And this project represents an attempt to do that, to respond to what is a tremendous opportunity for the state of Maine, and that's offshore wind. I also want to take a minute to recognize some folks in the room from NM. I want to recognize Pam Buck, who chairs the Trade and Technical Department. This woman runs 20 men around in a really straight line, gets them to do it. I also want to recognize Griffin Goins, who worked to put this video together for the college, and Nicole Cody, who's the project manager for this. So I want to thank them for being here. I think this project represents a change in the way we do business, an opportunity for the state of Maine to tap into the resources the state has to address an opportunity that is not going to go away. So I'm excited about it. Thank you.
Thank you. Chris, could you add anything, thoughts on that?
Yeah, I think this is looking forward far into the future and seeing how we can collaborate. This is, we call it, in some ways like SimCity, that old game of creating and building blocks and being able to see what types of employment are going to be available, what types of systems. I'll give an example. Paul was talking about this 1/8 scale turbine that was towed down from Brewer, right? So that 1/8 scale made 100 tons, something like that. When we get to the full scale, we're talking about 12,000 tons football field across, and you need the ability to have absolute precision around how you manage something like that. It cannot be momentarily out of control. So part of it is really getting everybody used to doing that sort of manipulation of major equipment. And so what we see is that this collaboration, particularly as you build that around the research array, really creates a laboratory to be able to do that and make sure that everything, your health and safety, right? Make sure that everything is done precisely.
Oh, okay. Thank you, Chris. So again, a follow-up to that really is, what is the significance of offshore wind to the state of Maine and the region? So you touched on it a little bit, but could we add some thoughts on that?
Sure. I think the significance of it is huge. I think the chance for us to make a difference in the environment, if you're traveling around the country today or in the state of Maine today, we're having one of the hottest summers we've ever had. We have an opportunity to have an impact on improving that. Okay? Offshore wind can be a piece of that. Maine can play a role in that. So it's significant from that standpoint. It's also significant that it provides opportunity for people to have good paying jobs in the future. This is a long-term project, and it leads us to a better future for the state of Maine and for the environment. So from those 2 points, I think it's very significant for our state and for our country, and to some extent for the world.
Okay. Thank you. Next one, more towards Wayne and Tim. So what does curriculum development look like from the technician front?
The curriculum development is stuff that we've been working on for several years now. So we'd be looking at, as Tim mentioned, looking at the safety aspects. So far, with what we are doing within the U.S. has been using the standards ANSI, NFPA, and then whatever OSHA requirements would be for working at heights, walking or working surfaces. So that's one of the cornerstones of the program. The other components of it are understanding electronics, power electronics, process controls, and also mechanical systems and how all of that stuff works together. So that's the type of things that the technicians will be working with. And going back to some of the other stuff also, the program we have at Northern Maine Community College for about 11 years now, we've been bringing students down to Maine Maritime Academy so that they can go through STCW and Hewitt, which is helicopter underwater egress. So we've had a partnership with Maine Maritime, actually pretty much from the time we started. And that was because offshore wind, not necessarily in Maine, but in Europe and some of the other locations. We're also looking at getting that kind of information to the technicians if they so desire to go in that direction. So we've had other than this, we've had quite a long relationship.
Up on the screen here, marinizing Maine's workforce. That's what we are going to want to do as far as this program is concerned at Maine Maritime Academy, helping those individuals who have been possibly working ashore but now want to work offshore on those towers, so that they, if they fall overboard, they know that they don't just have to swim, but they have to stay alive. So we're going to teach them how survival at sea if that ever happens, like Wayne was talking about. But something else that we're going to be working on, in addition to the wind itself, is also dynamic positioning. So we're right on the cusp of getting our own dynamic positioning simulator to assist those who are going to be driving those boats, while working towards getting those very large units out to the positions, so that we can train them so that they can pinpoint where those actual units are going to be positioned through dynamic positioning. And also we're going to be providing limited license, master licenses up to 1,600 tons. I mean, we do that at Maine Maritime Academy now, but we also tie that in with an actual degree. Well, somebody that wants to get a 1,600, 500-ton license, they don't have to have a degree to do that. So what we're going to do is try to squeeze that into a little bit more manageable time frame for people, so that they can start working in this area of offshore wind.
Yeah, thank you, Tim. So Sadie, you mentioned your class, so can you talk a little bit about that from your end?
Yes, I'd like to talk about that. So I mentioned that when I came back to teach at Maine Maritime Academy that I wanted to make a few changes. Some of the changes that I saw that we needed were updating the curriculum to include renewable energy. A lot of the students who came into Maine Maritime Academy, especially a power engineering technology major, told me that they wanted to learn more about renewables and then go out into the field and work in renewable energy. So I listened to that, and I developed the onshore and offshore wind energy course. Right now that course is an elective, but what I have are quite a few students who come in from the PET, or Power Engineering Technology program. We also have students coming in from the marine engineering side, the Marine Engineering Technology program. So we teach about the different types of support vessels that are needed to support offshore wind. We talk a lot about the maintenance and reliability aspects. We learn about site permitting. We learn about what it takes to permit both onshore and offshore for wind. I've worked with several industry leaders, both in construction, permitting, operations, maintenance, looking at remote operations, continuous monitoring, those sort of individuals. They come and they do guest lectures so that the students can hear directly from the folks in the industry and what some of the challenges are. So that's what the early teaching is looking like, and I really like to incorporate the folks from the industry to give some of their experiences. So that's what we're trying to do.
All right. Thank you, Professor. Next question to you, Chris. Could you talk a little bit more about the research array and what that means to this and future projects, and also at what point do you expect we'll get some data from the research array on what the larger implications are?
All good questions.
Okay.
Thanks. Thanks. So the research array is a project that was conceived of to be built several years before commercial scale projects are built. So it's 10 turbines about 40 miles east of Portland. And the concept of the research array is to set best practices for how large-scale projects will be implemented in the Gulf. Two pieces to that. One is to foster coexistence with fisheries, get people used to fishing around these in a safe manner. But for this team, it's also about sort of maximizing economic development locally and making sure that the way that offshore wind farms are built in the Gulf of Maine really build upon ports, manpower and methods and procedures that can make sure that essentially nothing goes wrong. Now, there's some real specific elements where it kind of works for all of us here. Is it's a really useful platform for apprenticeships, right? It is great to be able to take the newer people out, show them the hands-on, get people trained, before all of a sudden there are 200 wind turbines in the Gulf, right? And all of those people need to come from around the world. But there are also more really specific hands-on. These are going to be fields of wind turbines that are 40, 50, 60 miles offshore. So imagine in storms, right, the possibility of having a safe harbor for vessels in distress. That needs to be exercised. People need to know how to get onto these, get to that safe harbor, and then get evacuated by potentially helicopters or vessels and things like that. So there's a lot of what we call sort of a laboratory effect here for people to really see how to work on offshore wind at a small scale before it becomes large scale. Now, in terms of sharing that data, it's kind of the concept first of it's open platform where there will be research about how whales interact with wind turbines, things like that. So there will be research papers and such. But in terms of apprenticeship programs, it is literally open. It is going to be people talking, touching, feeling, being on vessels, turning wrenches, seeing what it's like to climb up in these towers when they're moving.
Oh, yeah.
In addition to sitting still. So,
oh, yeah.
So there's a lot to learn. And essentially, it creates the ability to learn at a small scale before you really go big.
All right, just following up on the people aspects. So Wayne and Tim, can you tell me the type of students you think that's going to be attracted to this program? And how many do you expect to be coming through?
I think the type of student that we have seen is a student that likes adventure, that likes a challenge, and likes to move. Okay, these are students that get a technical component, electrical component to the program, but they really like to be engaged in hands-on learning. So those students we have seen, and I think we'll continue to see. I think the other thing that we will see is students who will need to bring more technical, the ability to learn technical skills, because the jobs are going to become more technical as this evolves. So we talk about math skills a lot in our electrical program, in our wind power program, but those are really fundamental. So we're looking for students who have a greater aptitude in mathematics, are willing to work at that, students who like adventure, and students who want to move around. These jobs move. We have students working in Europe now. We have students working in Mars Hill, Maine. These students move depending on where the work goes, and there's wonderful opportunities for them. So I think we're looking for students who like some adventure, are physically fit, capable to do the work, and want some excitement in their life, and this will give it to them.
That's for sure. So a lot of the students are right out of high school, and they'll be looking for one-year certificate that they can get out and start working in the field and start earning some money. Again, as President Crowley mentioned, someone that likes to get around, someone that's not afraid of climbing a tower, right, 300 or 400 feet in the air. And yeah, they'll move about 6 to 8 feet when you're on the top, but that's on shore, okay? I'm not quite sure how far it's going to move when it's on a floating platform. A tube tower is a big spring, right? So if a spring doesn't come back, then you get some issues. But yeah, steel has a lot of give to it, so they will move. So someone that's climbing the tower has got to have a feel for that. As far as the GWO, the Global Wind Organization portion of it, a lot of them are going to be students, prospective students that will be coming back for training, this extra safety or technical training portion that will be above and beyond previous technical training. GWO is not designed for someone fresh out of school coming in and learning all this stuff. The motivation or the premise behind it is that they're adding this certification to an existing technical background. So they're going to have a certificate or an associate's or a bachelor degree in some technical format that they're going to be adding this piece to it.
So Tim, can you talk about the DP student and those types of students?
Well, I think, President Crowley brought up somebody who likes adventure. I think, I think anybody that graduates from Northern Maine Community College is adventurous just to go to Northern Maine. And of course, anyone who comes to Maine Maritime Academy is looking for adventure because they're going to be out there on the high seas and such. So I think us being partnered within this, I think is going to be very, very good for whoever decides to come into this program. But I don't think it's going to be just for someone right out of college. I think it could be someone who is looking for a change in career, someone who is looking for, maybe President Crowley brought up travel, because you can be a traveling technician very easily because windmills are all over the world. There's no question about that. So I think you know, the mixture of individuals coming into this training is immeasurable, really. If somebody really finds out what the possibilities are for what is going to be happening within the next 10 years, I think Wayne's class is going to be so full that he's going to have to be doing his training out on the lawn because he's not going to be able to fit everybody into his lab. That's what I'm hoping for anyway.
Thank you.
Do you mind if I
Sure,
jump in
absolutely.
and just
Please
add a
do.
little something to that? I can't help but connect the dots just a little bit, given where we're located, that this is the former Bucksport paper mill site, and we're looking for different industries to kind of fill those gaps. Just a generation ago, my parents' generation could graduate high school and go get a job in the local paper mill. So I see this as a real opportunity for Maine students to come out of high school, go into a technical field and get an education, like you said, to travel. So I see this as something that'll bridge that gap.
Very much so.
Yeah, thank you for that, Sadie. Just following up on that, Chris, so, you know, we talked about the 1/8 scale three-legged stool, as Paul mentioned, but how's the technology evolving? So how do you see it evolving in the kinds of things with the research array, you know, that jump in the change and evolution of the technology? Can you talk a little bit more about that?
Yeah, glad to. So as many of you know, the University of Maine has been working on a floating foundation, right? Basically all of the offshore wind will be floating off the coast of Maine that is built out of concrete, right? And that is largely because to enable it to be built here, right? A lot of this industry is built on steel, right? Steel, the structures that you see in the background here, those were fabricated in the Gulf of Mexico because even though they're located off the coast of Rhode Island, there's no steel industry really in the Northeast to speak of. So the idea really is to commercialize the university's foundation design and be able to create a supply chain, right? So if you imagine this, what you see in the background here, the foundations were built in the Gulf of Mexico. They were shipped up to the coast of Rhode Island. They were painted there, put through the final fabrication. The turbines came from overseas. The cable came from overseas. The idea really here is to further the technology development as an integrated supply chain so that there would be a port built in kind of nearby here, Searsport, and that port would be, you know, kind of rivaling the size of Bath Iron Works. So a big port, hundreds of people working each day in constructing these. And the technology research is really around how do you most efficiently create a factory, if you will, so that each one of these isn't built like a one-off Rolls-Royce. It's that you set up a factory so that you can work through the winter. You can have pieces fabricated inside. They go to final assembly, come down a ramp of sorts, right? You guys pick them up, tow them a little ways out, right, into what we call wet storage. Turbines arrive, and they get erected on the foundations, kind of in sheltered waters, and then towed out to sea to eventually be moored with 6 mooring lines. So all of this is not really what I would call research. It's figuring out how to actually do it, and then do it cost effectively. And each step is scrutinized in great detail. In addition to the University of Maine, we'd be working with 24, basically, subject matter experts to figure out the best most cost-effective, and ultimately safest way to deploy.
Thank you for that. So this is a slight switch now back into maybe a more historical context. So with an eye towards helping clean energy fit in a state whose maritime history and industry is so significant, can you share the steps being taken to ensure that there is equitable access to the water involving, so the whole panel, but you could lead off, Chris.
Well, that is quite a topic, equitable access, right? So there's a good history here too, where there was legislation passed 2 years ago to make sure that offshore wind wasn't going to be built within 3 miles of the coast, because the vast majority of lobstering takes place in those coastal waters. But I think a big part of it is to make sure that wind farms do not block other uses, right? That you can actually coexist. How that is worked out is yet to be determined. It's built to a certain extent on what the actual use will look like. And we're working on tools to be able to visualize. You can imagine these wind turbines bobbing around in the water, right? They have got mooring lines that sag down, and then they're attached to anchors, right? And so there's a lot of space between them. There's like a mile between wind turbines. These anchors only go out to the, or mooring lines out to the anchors, maybe 1,500 feet. But it depends on which way the wind's blowing, right? As that whole wind farm shifts to the left because the wind is blowing this way, that mooring line is going to pick up. So part of it is to make sure that that access around a wind farm, that all of the underwater infrastructure is clearly marked, so that as fishermen want to work amongst it, they can know where the mooring lines are, where the electrical cables are, and what the risk would be at any given time of a big windstorm sort of moving it off center. Now, they don't move off center much. It's kind of remarkable. They're off station just about 100 feet. Not even that. Stan probably in the back can correct me, but it's not far. So a big part of it is learning from what you see in practice at this small scale of research.
Yeah, President Crowley, can you talk a little bit about the marinization, the rest of the workforce, the other workforce elements that might be related to some of this?
I think, first of all, I live in Caribou, so talking about access to the water and the ocean is just like a different thing for me. But we're about workforce, and we're about developing people to support the industries in Maine, whether it's on the coast or it's in the woods, and we do that. So the challenges for the workforce in the state of Maine with this are that we have to really help people see the opportunity, whether they're in Presque Isle or Caribou or Portland or Kittery or Greenville or Eastport, the opportunity to be part of something that's going to make a significant difference in our state and in the world. And so we train welders, we train culinary arts people, we train all kinds of technicians in the electrical area. They need to see the opportunity in winds so that they can translate those skills to this industry if they decide to do that. If the industry makes it inviting enough, they will. So the opportunity to expand the vision that our students have, to see the opportunity for the skills that they have. Something I need to remember is that when engineers get involved, they need technicians, okay? And we train the technicians. So we think we're in a pretty good spot to work with the companies that you're talking about, with the organizations you're talking about, to support a workforce that can have a vision for how they can have an impact in this industry, whether they're in culinary arts or they're in welding, or they're a wind turbine technician, or they're in healthcare. There's an opportunity for all of those in this industry, we think. And that message we need to get to the people of the state of Maine, the students who are looking to get involved in this industry.
Okay, great. I'm going to nerd out a little bit, but Wayne and Sadie, can you talk about some of the technologies that are kind of behind this in terms of the turbines or the sensor technology?
Sure, yeah, sure. One of the things that we're going towards more and more stationary as well as offshore is continuous monitoring. So we'll have a sensor that's on the equipment that can be monitored from the shore. So you can be looking at a remote operating station and seeing that there's a fault and then sending a technician out. So these offshore wind turbines are going to be unstaffed until there's a problem. So there'll be less preventative maintenance, more predictive maintenance. So you'll have like I said, this continuous monitoring, operating from an offshore station. And I think that that's one of the strengths that Maine Maritime students already have as well, is not only do we have project management strengths, but we have remote operations capabilities. We already have students doing those types of jobs out in the workforce. So that's another way that I think that we can make a good connection.
Yeah, the equipment is fully autonomous power plants. They get that large rotor assembly in the front of them, which drives a generator. And so the communication system is all on a network, as Sadie mentioned, that supervisory control and data acquisition, SCADA, if anybody's worked with technical stuff. It will give an indication of monitoring of temperatures, vibration, and any issues that might come up are flagged. And so the information in most cases goes to a central location. Depending on the company, it could be in New York, it could be in Pennsylvania, it could be in Portland, Oregon. But all of the different farms within the US, all that information goes to these different sites depending on the manufacturer. And if somebody's not on site in the evenings, at night, holidays, yeah, they can pick up a phone call or send a text message and say, hey, turbine number 1 down in Berwick needs to have something taken a look at. So that information is passed along. So everything is network. You know, as most of you have your text messages and all your internet connections and stuff, yeah, these are all fully automated systems that are all on the internet as far as the access to them.
Yeah, so one last question for the whole panel now. So I'm asking you to put on your soothsayer hat now to tell me, do you have a crystal ball prediction on how all this is going to evolve in terms of the emerging technology, the opportunities, and just some closing thoughts?
Well, I'll jump in to break the ice. So one of the context of offshore wind is that for a lot of the states to achieve, and it's countries around the world, to achieve their carbon goals, it requires the electrification of everything. And by that, I mean not just stuff that you currently plug into the wall now, but it's cars, it's basically all transportation. And it's all heating too, heat pumps and things like that. So that will require a lot more electric generation. And so what it appears, so in a state like Maine, the prediction is 2.5 to 3 times the amount of electric power plants that we have now, whether it's wind turbines or gas-fired plants or whatever it is. And so the crystal ball is that building, the beauty of offshore wind, right, is it really, as we call it, really rips in the winter when you need heat, right? And so I think what I see is that this is not just a build it once and it's over, people maintain it. It's going to take 15 to 20 years to build the capacity that we need. And by the time you're done building that last one, you need to replace the first one. So it's kind of like a virtuous, continuous cycle where we'll be building wind farms and then taking down the old ones, putting up new ones, all the while having hundreds of folks maintaining the fleet that we've got. So I think it looks to me like it will be sort of a permanent industry. It's just a new face of the marine industry in Maine.
Thank you.
Can I build off that
Yes,
next?
please do.
Okay,
Yes.
excellent, thank you. So one of the things that we teach about in the Power Engineering Technology program is balancing the grid and how wind energy is intermittent. So my crystal ball, when I look into it, I think, how are we going to take all of that excess and store it for when we need it? So I think that that's going to be the next big thing that gets tied in with wind energy is some sort of storage. And I see that just based off the things that I've read and things coming out is hydrogen production, that'll be tied in. The next thing I see.
I think we really don't know where it's going to end up. We know where we're starting today, but it's going to change. I think one of the things that will be important is the security of our electrical grid, security of our systems. I think that is something that the interest in that will grow. It's growing now and it will continue to grow, because if we are tremendously dependent on electricity and we don't have secure systems, then we're vulnerable. So I think that's an important piece that will develop as this evolves.
I think a big thing as you see more and more turbines that are put up, you're going to see a lot more interest in either people that have been in industry for a while wanting to be retrained to get into this new industry, or you'll get a lot more excitement from the younger folks you know, your K through 12 or anybody that might be going for an associate's, they're going to say, you know, that's a viable industry I can get into. And so I think you're going to see a lot more excitement when you see more equipment that's available.
And to build on what Wayne just said, it's retraining constantly. So even though, like you were saying, Chris, 15 years and then you got to replace, but at the same time, during those 15 years, everybody has to be retrained, brought back up to safety specifications and so forth, because it's not going to stay the same throughout the next 20 years. It's always going to be improving upon itself. And that's what our partnership is all about. Providing the foundation and then assisting through that retraining, improvement throughout the rest of their career cycle.
Thank you. I want to thank our panel for some very insightful comments and thoughtful answers. So a round of applause to our panel. Thank you very much.
Thank you.